Hello, everyone. Good morning.
Good morning, friend. Good morning, all.
Morning all. Yeah.
Okay. Okay, let me share my screen. Okay, I hope my screen share is visible. Any quick confirmation?
Yes, it's visible.
Okay, so we'll start off with today. Yesterday, we had a quick demonstration of what exactly we are going to learn in this course. And today, we will directly get into the understanding of accessibility testing. And let's also do some little homework, which is like some basic prerequisites understanding in today's day one class. So I'll use this rough document that I have opened to write. So let's also check the basics now. So we'll start off with what exactly is software testing. Then we'll talk about overview of software testing techniques. Okay. So I'm sure everyone is aware of what is software testing, right? I mean, you have been doing software testing in your career. So everyone is aware of it. So I'm not going to give you a definition of it, but rather talk about software testing in a different terminology, where I will say that an activity called software testing has got two objectives, a primary objective and a secondary objective. And that itself will give you the definition also. So when it comes to the primary objective of software testing, it is not about finding bugs. It is not about executing test cases. So the primary objective is to ensure whatever application is given to you by the developer, to ensure that all the client functional requirements are developed in the enterprise application, which means whatever TRS document or SRS document you receive, right? The functional requirement, the functional specifications document, or all those functional requirements or specifications, have they been converted into executable code in the developed application? That is the primary objective. So I can write here, the definition is verify if all the functional specs, nothing but requirements, are converted into executable code in the developed application. That is our primary objective. So the client has given you technical requirement document. In that he said, as a user, I should be able to enter my username. As a user, I should be able to enter my password. As a user, I should be able to click on login and log into the application if the user credentials are valid. So those are the functional specifications given by the customer. And how do you validate it? Obviously, by looking into the application that was developed. Example, if I take some simple application which has login. So this is the application the developer has given to us. And I see, okay, there is a text box given. So developer converted that requirement into executable code where I'm able to enter a username. Then there is a text box that accepts password. So the requirement which says the password box should be available for user to enter password, it's executed into the code level and it's available. Third requirement, as a user, I should be able to click on login. Yes, I have the login button. I'm able to click on it. And the requirement says you should be logged in if the credentials are valid, else an error. So I got an error that my credentials are not valid. So the primary objective is met. And if I want to check a positive scenario, I have to provide a valid username and a valid password. And if I click login, yes, I'm logged in. So the functional requirement of the application has been specified, right? So a check like this is nothing but primary objective. Now then what is a secondary objective? Something that you have been expecting. It is the process where our focus will be on finding the bugs in the developed application. Now when we say bugs, we should obviously understand what do we call a bug, like what exactly is a bug, right? A bug is a difference between the expected result and the actual result. Expected result is what everyone in the world is expecting. Actual result is the result that your application is giving. A simple example is if I open this calculator and I wanted to do 5 multiplied by 6. So everyone in this training is expecting the answer as 30, right? So expected result is 30. And when I execute this operation on the calculator is giving some number, in this case 30. So whatever calculator application is giving, that is actual result. It could have given me 31 also probably if there is a mistake. So my expectation is 30, but the application is giving me 31. So my expected result is not matching actual result. So I would term this as a bug because there is a deviation in terms of expectations versus reality. That is nothing but a bug. And that is typically our secondary objective. So the secondary objective can be defined as to capture all the possible bugs in the developed application. Okay, so I will say to capture all the possible bugs. If you see here, I'm using the word possible. If I remove the word possible, it means to capture all the bugs. Now, there is no limit to the number of bugs present in an application. No test engineer can unearth all the bugs. Never possible. There is always a scope for some bug to be present in your code somewhere. Therefore, we say try to capture as many bugs as possible or all the possible bugs, but never all the bugs. Remember that. Excuse me. To capture all the possible bugs in the developed application. That's our secondary objective. Okay. And since we use the word bug, let's also write here what is a bug. So I will say a bug is a deviation from the expected result. Or I can also say a bug is a deviation from the client expected result or from the client specified requirement. So client has told you this is how the application should work, but our application is working in a different way. Then definitely customer will say, hey, this should be treated as a bug because that's not happening. Am I clear until this point to everyone? Like what is software testing, the primary objective, secondary objective, and do you have any questions until this point?
No, Kiran, it's clear actually. Yeah.
Okay. Okay, let's talk about the overview of software testing techniques and some methodologies. Typically, this is a common question being asked in the interviews for junior folks. Like, can you explain all the software testing techniques, right? So this can be answered differently by different people, and we are not here to judge which is the right answer, but we will talk at a holistic level. So we can classify software testing, into multiple categorizations. So I will say we can categorize it as black box testing. Then we can categorize it as white box testing. Then we can categorize it as gray box testing. And there it won't end. We can also categorize it as manual testing, then automation testing. That's another way how people can also categorize it, right? But that's not the end again. We can categorize it further as positive testing, negative testing. And do you think that's the end of it? No, we can still categorize it as destructive testing, another activity. And after that, further, if I go, we can categorize it as functional testing, non-functional testing. Software testing. So how do we define black box testing? Can anyone from their perspective?
We have to test the application without going to the internal code check. Like without going the implementation of the application, we will just check the functional behavior of the application.
Okay, perfect.
Yeah, we'll give an input, a valid test data as input, and we will check the outcome of the application actually. And we are not bothered about the implementations. Yeah.
Correct. Yep, that's right. And hence the word black box is used, right? Because if a box is painted black, you cannot see what is present inside the box, right? Because black color does not reflect what is present inside, right? It stops. It's like opaque thing. So the definition of black box testing is whatever you have said. That's perfect. So in black box testing, the test engineer need not have any programming language skill set or database language skill set, front end or back end or database or server language skill set. In fact, he need not know the architecture of the project or the framework of the project also. His job is to gain access to the application, provide some input data to the application, validate the output coming from it, which means provide some request and validate the response. Something like if I ask you guys to test this application, if I ask you to test this username, password, login functionality, will you ask me questions like who developed it? What is the programming language used? What is the backend language used? What is the database used? What is the developer name? What is the framework used? We don't ask those questions because we don't need it. You want me to test login? Okay, fine. I will provide some invalid inputs and click on login. It should not log in. Yes, it's not logging in. Fantastic. I got an error. I'll provide valid username. I'll provide valid password. Yes, I should be logged in and I'm logged in. That's it. So that itself is your black box testing, right? So the definition of it, again, I'm not interested in giving you the definitions. You're all good at it, but we'll write some pointers over here. So I will say here, the test engineer need not have knowledge around the project implementation areas, such as programming languages used in front end, back end, database side, server side, or the frameworks used. Okay, so when I say database side, such as database name, tables names, columns names, etc. Server side infrastructure, development frameworks used, etc. You don't need to have all that areas of knowledge for a black box test engineer. All of us, right? We all started our career as black box test engineers, and maybe today also we might be still black box test engineers. And I can say here, the test engineer provides what? Inputs. The input can be a valid input or invalid input, because you might be doing, the positive testing or negative testing. So the input can be classified as valid or invalid. Here, the test engineer provides valid or invalid inputs to validate the application output received. Okay, so to validate the received application output. That itself is nothing but our black box testing, right? I hope this is clear, right? This is what you mentioned, and that's what is there here. Any questions here?
No,
No,
no.
Kiran.
Okay, guys, just give me 1 second. I have to mute myself. Just 1 second. Yeah, thanks for waiting, guys. Let's talk about now white box testing. So when it comes to white box testing, it is pretty much opposite, right? Against the definition of black box testing. So in white box testing, the test engineer is definitely focused on the project implementation areas. He or she needs to have understanding about all the programming languages used in the front end or in the back end or on the database side, meaning the test engineer says, I need to know the database name. What is the database type? What are the table names? What are the data types used? What is the data length of each column name used? What kind of data do we have? What is the foreign key? What is the candidate key? What is the unique key? What is the primary key? What is the size of the database we are expecting? So a lot of questions will be coming in from white box testing because he or she comes mostly from a programming language or development background. And their job is not blindly giving an input and validating the output. Their job is to check the testing process at the code level. So a white box test engineer, when I tell him, hey, this is the application you have to test, he will say, I don't want this. I want the source code written. So give me the access to GitHub repository and I will go through the source code. I will do the unit testing at the source code level. I will run the code. I will check whether the syntax is correct, whether the logic is correct, whether the functions are used appropriately or not, and whether any outdated functions or I would say what do you call dead functions, meaning functions which cannot be executed or which won't run during its lifetime, or if the developer has used some functions which are not considered secured because they are outdated. So all these kind of questions will come typically from a white box test engineer. So that guy is probably a champion of testing if you ask me. He is not interested in providing a valid input or invalid input and validating the output because he knows that black box tester will take care of that activity. So whatever is a loophole present in black box testing, such as we are ignoring the project implementation areas. So that is something your white box tester will focus upon. Okay, so here if I have to write, I will say here, the test engineer focuses more on the project implementation areas, such as I have to just copy all these things. Okay. Is this also clear, guys? Example, right? I mean, in case if you want an example of it, I will say if I have written a small program, right? Let's say integer a, integer b, c equals to a plus b. Okay, and then I'm saying printf c value is and c. Let's say this is what I have written as a small piece of code. Okay? This is and c or plus c, whatever. Now here, what the white box tester will do is he will probably ask the developer. Let's say I'm writing one more thing here called integer d also. And here the developer, the white box tester will say, you have not imported the necessary packages. So that is one comment he will say. Something like in C language, we use hash include stdio.h if it's a C language. If it's a Java programming language, you will have import io.java.star, whatever is a package. So these statements are missing. So that is one comment he comes. And he says, this variable is never used, though declared. So you are wasting the memory by declaring a variable, but it is never used in the code given to test engineer. That's second comment. Then you are saying C equals to A plus B, but what is the data type of C? Whether it is an integer or a character or a string or a double or a float, that is a problem. So data type is not declared. That's another problem, right? So like this, the comments will come from the developer, and probably he might also say you could have done even exception handling if needed for this. Okay, I'm just giving that feedback here, but this particular small code does not need exception handling, but assume that this could also be one kind of feedback. So this kind of code, the feedback is what you get from a white box tester. A black box tester will simply say okay, another thing I forgot is the thing is values are not defined for A and B, right? We have not defined what is the value of A, what is the value of B. And the white box test, the black box tester will simply say, if I have given A and B as 1 and 2, the answer should be 3. So is 3 coming or not? That's it. He won't see the internal details. This is nothing but the internal details. So the black box tester says, I gave 1 and 2, the answer is coming as 3, test case passed. And he says, okay, this feature is working good, deploy it to the next environment. But if you go inside and see, there is a lot of buggy code written here. Lot of room is there for improvement areas. So all these things are missing in the code. Okay, so that's white box testing, guys. Am I clear?
Yes, Kiran.
Okay. Then we have gray box testing. This is obviously a combination of black box testing and white box testing. So naturally, there are folks in the industry who come from white box testing background and also black box testing background. So when the same person is doing both the black box testing and white box testing, which is a very rare skill set and a rare thing to happen in the industry, but nevertheless, if that happens, we simply use the word gray box testing. So this is your black box testing plus white box testing combination. And then if I talk about manual testing, I think all of us started our career, and probably even now we might have been doing manual testing, right? So manual testing typically involves a laborious process, a time consuming process where you write the test cases manually, where you execute the test cases on your own, nothing but manually. You report the bugs in the bug tracking tool like Jira or Quality Center or Mantis or Bugzilla. Manually only you will do everything. So every action is a manual action, right? Something like, I mean, if I take daily examples, example, if I talk about the training I'm doing, it's a manual training, right? I'm speaking. It's not a recorded session, right? It's a manual thing that I'm doing to you, and you're also listening at the same time. So it's a manual activity that we are doing right now, right? So manual testing is a process where the test engineer does every testing activity without using any tool, or he or she does on her own, on his own. Example will be writing the test cases could be a manual task. Executing the test cases could be a manual task. Understanding the requirements could be a manual task. Sending an email to the developer about the test report or about the bug summary report is also a manual task. Participating in your scrum calls and providing your updates is also a manual task. All these things comes under manual testing. Okay, so I'll say here the test engineer conducts all the software testing activities on their own in a manual way, which is a time consuming or laborious activity. Okay, which is a time consuming or laborious activity. Example could be designing test cases, executing your test cases, reporting bugs in the Jira tool, or sending emails, sending test reports via emails, right? And conducting your functional testing, your retesting, regression testing, etc. Whatever testing techniques you can name, all those things. You do all these things manually. And that typically is termed as manual testing. Now let's talk about automation testing. This is again quite opposite to manual testing. Here we are kind of little innovative. We don't want to work in a manual way because it is time consuming activity. So we wanted to bring some magic to that manual process. Example, if this training I don't want to do manually, so what will I do? I will say, okay, Mr. Yogesh, I'm not interested in training you because I'm a lazy guy. I have the recordings of this training. So why don't you just listen to the recorded sessions? Yogesh might say, yes, Kiran, I'm happy to do that. So I have automated this training, meaning at least with one student, I have automated it because I'm not speaking anymore in the morning, 8 o'clock my time. He is not listening in the morning, his time, 8 o'clock, but it's automated. He can listen to the recorded session probably in the afternoon, in the evening, in the night, early in the morning, whenever he wanted. That's like automating things, right? We did some little bit of magic and both the parties accepted it, right? And another example is, see, let's say, after this program, obviously everyone has a habit of having their breakfast. So the breakfast could include something, probably a dish that the family member at your home makes. Probably my wife says, okay, Kiran, I'll make you, something like idli or dosa. So, but that's an activity she has to do in the kitchen. It takes like 30 minutes to 1 hour process in preparing the flour, etc., everything. And what if I say, no, let's purchase that 10 rupees Maggi packet and 2 minutes, 3 minutes, you can just cook it, boil it, and give it to me. So that's an automation, right? Maggi is half made, a dish, I would say, and you have to just boil it in water, add some masala, and then it's ready. So eating Maggi now can be termed as automation for me. Whether I eat it in the afternoon or morning or evening doesn't matter, but that's automation for me, right? Or if I put maybe that pizza flour in my microwave oven, and that's also automation because almost everything is done. Because in the supermarkets you get ready-made processed food. That's all automation, right? Similarly, in our daily life, the way we have manual cooking and automated cooking, we are talking about manual testing and automation testing. So whatever task the test engineer is doing manually, example activities I have listed here, he or she will convert them into automation by using some tool, right? So let me say here, the test engineer conducts all the software testing activities via an automation tool which is quick and does not consume much time, thus making it less laborious activity. Example of this could be designing. I think I can copy all these things. So designing your test cases can be done through automation. Executing your test cases can be done through automation. Reporting the bugs in Jira can be done through automation, etc., etc. All these things can be done through automation, right? Another example of automation, right? If I just want to tell you, if I open my spreadsheet and let's say our requirement is to write some numbers, because for whatever students I have in my course, I would like to assign some numbers to them. So here I will write the names of the students. Let's say the username is Aarti, and then Yogesh, Isha, Kiran, Vipin, D. Let's say, these are the people we have listed here. So I wanted to give some IDs to them. Okay. So manual process is, giving something like, I wanted to say my IDs starts from 101, then 102, then 103, 104, 105, 106. So this is manual process of writing the IDs. Otherwise, what I can do, right? I mean, if you write the first one and second one, Excel has that, intelligence. If you just do this drag and drop, the numbers are automatically populated, right? If I do it further, the numbers are auto-generated. So this is nothing but automation, right? Because I'm not doing manually. I'm using some intelligence of the Excel sheet and generating the numbers based on the first two logical numbers I have written. So that is also automation for me. Similarly, we can generate random names also. There are so many functions, right? If you go to formula, there are so many functions available here. All these functions, nothing but automation only, right? If I want to find the sum of all these numbers for whatever reason, I don't do it manually. I use this function, sum of these numbers, and I get it. I can also say maximum of this number, get the maximum number. I wanted the minimum of this list for assuming that it's some related to finance. All these are automation that we are doing, right? So we do automation every day. Automation does not exist only in testing industry. It is there in every industry. In healthcare, it is there. With the doctors, it is there. In the manufacturing industry, we have fantastic automation, which does not even exist in software testing industry. In daily life, we have, of course, in software testing and development also, we have it. And so there are a lot of tools these days, especially with the invent of artificial intelligence. There are so many tools. If you just Google it, you will find it. The tools can read a requirement and give you a test case accordingly. You have to just say, okay, my requirement is I should be able to log into the application if I provide a username and password. click on generate a test case button, it will generate some 10 test cases automatically. So test cases, who is designing it? That tool is designing it automatically. So that's automation. And then you automate it via Selenium. Okay, example, if I take Selenium or Rest Assured as automation tool, you write the code to automate your manual test cases. So writing the code in automation is manual process, but execution is automated because you just click on that play button and then the code automatically executes. It opens the browser, it inputs the username, password, it clicks on login, and then gives you a report whether the test case has passed or failed. That's nothing but automation testing, right? And these days we have tools and automation logic where the moment your test case fails, the automation tool, Selenium or Rest Assured, it will only go and raise a bug in Jira. You don't have to log into Jira also, because you have already coded everything in the tool that in case if the expected and actual result do not match, these are my Jira credentials, the URL, the username, password, this is the project name, this is the post API. So just execute this API and raise a bug in the Jira tool and assign it to my development lead. So the code is executed automatically. If it has passed, happy. If it has failed, the bug is raised automatically in the Jira tool. That is also automation. And after all the test executions are completed, today people are sending emails manually, whether he's a manual guy or an automation guy, right? But we have logics built into so many tools today that once the test suite execution is completed, you can send an email automatically. And you can configure the logic, send an email if all the test cases passed, or send an email only for the failed test cases, or send an email no matter what, whether test case passed or test case failed, or no matter what, test suite passed or test suite failed. All these things can be automated. Okay. And when you say I'm using Selenium for my project, or I'm using Rest Assured in my project, we say we are doing automation testing. But actually it is semi-automation testing, because you are writing the code on your own. That's a manual process. Execution of code is only automated. Designing of automation code is still manual activity. Reporting the bugs, if you're doing manually, though you are a Selenium test engineer, then I call it as partial automation or semi-automation. Are you sending emails manually even after automation testing execution is completed by Selenium? If you say, yes, Kiran, I send emails manually at the end of the day, then it's partial automation, semi-automation. If you automate every activity that is possible, you are moving slowly from semi-automation to 100% automation testing. And today the industry is looking only for those automation specialists. Not today, from the last 10 years, that is actual definition of automation testing. Am I clear, guys, on automation testing?
Yes, Kiran.
Yes, Kiran.
Okay, then we'll talk about positive testing. I'm sure you might have heard of positive testing, right? So it's typically a testing technique where the test engineer focuses on the positive aspects or positive workflows of your application, meaning the intention of the test engineer is optimistic, the intention of the test engineer is positive, where his intention is to prove that the application will work. His intention is not to find bugs in positive testing. His intention is only to prove that, yes, Kiran, the login will work. Yes, Kiran, the logout will work. Yes, Kiran, I can make a payment to my customer. Yes, I can apply for a home loan. So you are able to prove to the opposite guy that the workflow is working as expected. So you're being very optimistic person. And usually we do positive testing in scenarios like when there is a demonstration you are giving to the client or to your management team. So to the management and client, you do not talk about, hey client, to do like this, you will find a bug. And the client will not be happy with your organization, right? Because to the client, you have to provide the confidence that whatever application you have developed is working. And to the management also, you are not there to show them the bugs. You have to show bugs to developers, not to management, not to client. So we do positive testing when you are doing demos or demonstrations to your management or to the client team. And when exactly we do it? Probably towards the last phase of your testing life cycle, because that's when you are about to release a build to production in your waterfall model or V model. If you're in agile model, then towards the end of the sprint, you will do positive testing to give that confidence to the Scrum Master that, you know what, brother, this is working. So that's called as positive testing. So I will say here, the testing is conducted with an intention to prove that the developed application works in all the agreed business workflow scenarios. We usually conduct positive testing during the or towards the end of STLC or SDLC life cycle, or towards the end of each sprint in agile methodology. And we conduct positive testing during demos to the management team or client team. Okay, example, if I talk about any simple application here, I'm logging into the application by giving a valid username and password. So I wanted to prove to Aarti that Aarti is my customer. I say, hey, Aarti, you know what? We developed this, and you see, I have given the username and password. I'm able to log in. Aarti is like, fantastic, Kiran, it is working. And here I should tell her that, you know what? I'm able to book an appointment with the doctor. So I'm choosing a future date. I'm choosing that this person needs hospital admission in this particular city he's present. He has this insurance program. And the reason why he wanted to book an appointment is fever checkup. So after he fills the form, the user clicks on book appointment. And you see, we are giving him a confirmation message that your appointment has been booked. So this is a positive workflow that I'm giving to Aarti. So Aarti says, yes, I'm happy with this. And then I'll say, now that the user has completed this, he can click on history and see, you know, his historical attempts that he did with the hospital. So Aarti says, okay, you are maintaining the history. Very good. And the user then clicks on logout because his activity is completed. His task is completed. So that is a positive workflow I have demonstrated to Aarti because she is my customer. That's the approach I take in positive testing. And negative testing, obviously, you know, quite opposite of it, right? So I will say again, here, the testing is conducted with an intention to prove that the developed application fails. Okay, your intention is not to prove that it will work. Your intention is, okay, developer, look on my screen, I'm doing some magic and I will find a bug here. So you do negative testing mostly with your developers, not with your management team, not with the customer team, unless they explicitly challenge you to do that. So in negative testing, you are not optimistic, you are pessimistic. You have that out of the box thinking, because you know that, hey, I'm getting paid from the organization as a salary because my job is to find bugs. To find bugs, you should do negative testing, not positive testing. So here the testing is conducted keeping the intention as I will find bugs, that the developed application fails in the developed application. Okay, I already wrote in the to prove that the developed application fails. And when do we do this negative testing? Definitely not towards the end of each sprint, because when the sprint is closing, you are releasing a build to production or to customer. So there you should not find the bugs, right? You should do it at the beginning of the sprint only, or when you are giving demos to your Scrum Master or to your Scrum team, meaning to your developers. So I say we usually conduct negative testing in the initial stages of SDLC or STLC, or in the initial stages, or in the initial days of, or not initial days, or in the sprint beginning, or as soon as the sprint starts. Maybe that's the right wording. So as soon as the sprint starts in your agile methodology. And we conduct negative testing during, not during, we conduct negative testing during I would say functional testing, regression testing, etc., to the Scrum team or to the development team. So the participants here is development team. So here, instead of saying during demos, I can also say the word UAT to the management team or client team. That's negative testing, guys. Any questions here? Hope it's clear for all of you.
Yes.
Yeah. So example of negative testing will be, maybe I have my developer, so I'm logging in, and I wanted to tell the developer that there is a bug here. Like I will say, I chose a date which is already gone. So 3rd March is no longer there, right? It's an old date. And if I click on book appointment, the appointment is still getting booked. How can you book an appointment for a date that's already gone, right? So that's my negative testing approach that I'm doing. Okay, and in the history, you see my previous record is erased. This is the current booking I did on 3rd March. Then what is the, where is the entry of the future date I did 1 minute back? It's gone. So the history is not persistent. It's gone. After I log out and log in, I don't see any history. So now that I am logged out, and if I am logged in, and if I go to the history, you see the history says nothing is there, no appointments. So where is my history? So it's not being made persistent. So that's a bug I found because my approach was probably different negative testing. Example of that. And then we'll talk about destructive testing. Now, destructive testing is typically conducted during the important testing phases such as security testing, soak testing, endurance testing, load testing, or performance testing, or volume based testing, penetration testing. Those are the examples where we do destructive testing. Because in destructive testing, it's not about sending positive data or negative data. It's just sending lot of data to the database. Because if I say I'm doing load testing or soak testing, I might send thousands of requests to the server, or maybe in lakhs also I might send requests to the server. So don't you think the database will be like bombarded with thousands of requests, and it might even get destroyed, meaning the database has to restart automatically because of your destructive actions. So that typically is termed as destructive testing. And if you're doing penetration testing, which is a flavor of security testing, you send a lot of payloads with malicious data, with data which has a lot of programming language or cross-site scriptings or HTML injections or SQL injection code you are sending. And the database says, I'm getting too much of attacks. And the database might be shut down, might be restarted, might even crash, or the server can also crash. That typically is termed as destructive testing. So in destructive testing, you check whether the server or the database application has that resilience factor, meaning can it come back to the original state? Okay, it is like you are beating the server and database. Your question is to check, do you come back to your original state after a minute at least? Can you come back, or you die permanently until we manually restore you? That's like destructive testing. So I'll say here, the testing is conducted with an intention to bombard the server with loads of malicious, valid or invalid or CSS cross-site scripting scripts or test data to verify if the database or server has the resilience factor to restore on its own within the stipulated time. So every developer or every DevOps team will have that stipulated time based on the server infrastructure they have purchased or the capacity they have purchased from AWS or from Azure, right? And obviously, what kind of testing techniques we do here? So I will say we conduct destructive testing during load test, soak test, endurance test, volume test, big data test, penetration test, etc. Okay, and if you say, Kiran, when do we do destructive testing? Obviously, we do it not towards the end of the life cycle. We do it in mid of project life cycle. So I can probably copy one of these lines, or I'll put it right. We conduct destructive testing, this, etc. during the mid of SDLC or STLC life cycle, or during the sprint execution activities. During the sprint execution activities, meaning for every sprint you should be doing that if the customer has asked you to do destructive testing as well. Is that clear, guys? And finally, we have functional testing and non-functional testing. Functional testing, I'm sure everyone is aware of it. You have been hearing about it in your project, right? Functional testing typically talks about, it's a black box testing technique, by the way, and it's about, validating the developed application behavior by providing some inputs. Let's say you are providing valid inputs to cross-check whether valid output is received from server or not. Okay. Functional testing, it's also referred to as black box testing, where the output of the application is tested for its correctness and completeness, right? So under functional testing, you have so many testing techniques like smoke testing, sanity testing, retesting, regression testing, ad hoc testing, exploratory testing, user acceptance testing, system integration testing, database testing, end-to-end testing. All these testing techniques, they all come under functional testing. Simply say functional testing is black box testing. You provide inputs, you validate the outputs. And then we have non-functional testing, which is quite opposite to functional testing. So here we validate the application behavior around non-functional characteristics or non-functional traits. Okay, and non-functional testing can also be classified either as black box or white box or gray box, but based on the approach, we can further tell exactly. Okay? So here only the non-functional aspects are measured and tested by test engineer. So what are those non-functional aspects? Maybe the response time of the application is important for me to check. So response time is a non-functional testing attribute. You wanted to check how well the code is written functionality wise. That's a non-functional requirement. You wanted to check whether the code is written in a secured way. Is the application secured from cross-site scripting attacks? Is it secured from SQL injection attacks? Is the application developed free from man-in-the-middle attacks? They're all non-functional characteristics. You check whether your application is compatible with various browsers, various operating systems, various frameworks. Like, is the application compatible on Docker? Is it compatible on Kubernetes? Is it compatible on AWS, Azure? Lot of things you check in compatibility checks. Is the application responsive on different devices, different tablets, different smartphones, different computer screens, different television screens? They're all non-functional characteristics. And you also check whether the application is usable by every person in the world. Is it accessible by people who are deaf, dumb, speech impairments, color blindness, partial blind, full blind, motor issues, cognitive disabilities? So is the application accessible even for those people? That's nothing but your non-functional testing characteristics. So I wanted to reiterate the examples of non-functional testing. The loading time of a website is a non-functional testing attribute. The response time taken to log in into an application is a non-functional testing attribute. The ability to use this website on different browsers or different versions of browsers or different operating systems is a non-functional characteristic. And whether can I use keyboard and access the application and log in or do whatever I want only with keyboard without using mouse, that's also a non-functional characteristic. Okay. So examples of testing techniques where we do non-functional will be performance testing, load testing, stress testing, soak testing, volume testing, endurance testing, penetration testing, security testing, compatibility testing, usability testing, accessibility testing, UI and UX testing, localization testing, internationalization testing, screen resolution testing, they're all examples of your non-functional testing. Okay, I'm not writing all the definitions here. I'll give it in the notes. And finally, to conclude, we have discussed a lot of basic things, right? Like, I'm sure you're aware of all these things, and maybe some new learnings you might have got today after looking into primary, objective, secondary, and overview of software testing techniques. You might be wondering, in accessibility testing, why is Kiran talking about all those things? Probably you'll have an answer now. So finally, if I say, what is accessibility testing? I will say accessibility testing comes under non-functional testing. Accessibility testing comes mostly under black box testing, but there are examples where it also comes under white box testing if you're doing it at a code level. Okay. And do we do accessibility testing in a manual way or automation way? The answer is both. It is manual testing and automation testing. In the course, you are going to see both. Is it positive testing or negative testing or destructive testing? The answer is it is positive testing. Okay. So did I cover everything? Yes. So accessibility testing, which is our course main topic, it is a part of non-functional testing technique. It will be done as a black box testing most of the times, but developers can also do as white box testing if they are doing it. And a test engineer can do it manually, and he or she can also do it using automation testing. And is it positive approach or a negative approach or destructive approach? It is never destructive approach. It is mostly the positive workflows only we take. We don't try to give any negative data at all in accessibility testing. So if you have to classify accessibility testing, remember, this is how you classify it. And probably the definition of accessibility testing, usability testing, I'll do it tomorrow because I don't want to give definitions unnecessarily. Categorizations is very important for us because we should know whether the testing techniques we are learning comes under a particular topic or some other topic. So with that, we conclude our day 1 training program. And if you see our course, right? So in the curriculum, if you see, we have just completed the first 2 bullet points today. Okay. And whatever I'm teaching you, right, it's already there in my notes. So you don't have to worry about it. I'll take care of giving the access to the notes to you guys once I have the final list of enrollments. If you have any questions, guys, on day 1, please go ahead and ask me questions.
So usability testing we are going to cover tomorrow. Like I didn't get what is the usability testing. Is it like accessibility testing that we called as usability testing? Or
Yes,
if
we are
it's
going to cover it.
tomorrow?
Yes.
Okay.
I'll cover them tomorrow. What
Okay.
is accessibility? What is usability? What is the importance of it? I'm going to cover it tomorrow.
Okay.
Okay, then. Thank you very much, guys. I'll see you in the next class. And if you're happy with the flow, with the content I'm sharing with you, talk to Isha team and complete your enrollments.
Yeah, only one thing, like from next week, our daylight savings is going to start. So can we do like half an hour before? Because that time will be very late for me.
Okay, let me check with Isha, or you can also have a word with Isha. Maybe you can talk to them on the WhatsApp group. I'm okay because doing it half an hour early is like 7:30 a.m. for me. That is also okay for me. But I just wanted everyone's confirmation as well. So you can
Yeah,
check
like
with
with
Isha team on the chat.
other team also, like a Vipin or Yogesh, if they are comfortable.
Yeah, it will be too early for me actually. I have some work at that time.
Okay, fine. I think we'll talk to Isha team and see what best can be done. But let's see. In the interest of democracy, we'll take a decision there. I'm okay with anything, but let's talk to everyone and get their opinions.
Okay, sir, sure. Thank you.
Okay. Thank you, everyone. Take care. Bye bye.
Bye.
Bye.